everybody, and welcome to another episode of Adventures in Machine Learning. I'm your host, Charles Max Wood. I am going to tease that I have gotten a few of our past guests to agree to come on as future panelists. So keep your, I was going to say eyes peeled, but that doesn't apply. We're an audio-only podcast, so keep your ears peeled. I'm here with Ben Wilson. Ben is the author of Machine Learning in Action from Manning Publishing. Machine Learning in Action is a MEEP. I always say MEEP because I think it's funny. MEEP. It's a Manning Early Access Program book. And Ben is one of those geniuses over at Databricks. What's your official title? Resident Solutions Architect is what it says here. And he's a professional data science. I'm making you sound smart because you're smart. For more than 10 years. 10 years. Wow. That's like an eternity for programmers. But yeah, so data scientist for more than 10 years, which means he's more patient and smarter than I am. Resident Solutions Architect at Databricks focuses on machine learning and production architecture with companies, big companies, Fortune 100 companies, and 5-person startups, which means that he does people wrangling and big company wrangling. I don't know which of those is more impressive. And he's the creator and lead developer at the Databricks Labs AutoML project, which is Scala and Python. Scala is also patience, and simplifies machine learning using feature engineering, model tuning, and pipeline-enabled modeling. Boy, we should just get you back on and talk about some of that stuff too.
I remember working my tail off to become a senior developer. I read every book I could get my hands on. I went to any conference I could and watched the videos about the things that I thought I needed to learn. And eventually, I got that senior developer job. And then I realized that the rest of my career looked just like where I was now. I mean, where was the rush I got from learning? What was I supposed to do to keep growing? And then I found it. I got the chance to mentor some developers. I started a podcast and helped many more developers. I did screencasts and helped even more developers. I kind of became a dev hero. And now I want to help you become one too. And if you're looking forward to something more than doing the same thing at a different job 3 years from now, then join the Dev Heroes Accelerator. I'll walk you through the process of building and growing a following and finding people that you can uniquely help as you build the next stage of your career. You can learn more at devheroesaccelerator.com.
But yeah, so the book's not finished, but I kind of browsed through some of the stuff in the book. And yeah, there's a lot here. But where I want to start is it seems like there are a lot of books coming out on machine learning. And I'm always curious about, okay, so what's in this book that's unique? Like, who's this book for? And why should they pick this one up instead of one of the dozens of others that are coming out these days?
I mean, the reason I wrote it is because I remember quite intimately how unbelievably painful it was the first couple of times that I messed up a deployment of a model. And this isn't the CI/CD deployment of it. This is I failed to solve the business problem that I was tasked to do, or the solution that I came up with was so unstable and broken that I was doing nothing but supporting it all the time. Like, it would break every day because I didn't really know how to design it, how to build it, how to write code properly. I didn't understand how to monitor stuff correctly, to do attribution modeling, to do proper hypothesis testing. I didn't understand that some of the data was actually, the collinearity was actually affecting the performance of the model over time. So the intention of writing the book is to identify a lot of these cases, pulling from my own history and the breadth of history that I've been able to help other companies work through over the last several years, and sort of short circuits that really painful development path that people go through for ML. So the TLDR of that is it's the book or the guide on making ML and data science applications that actually solve a problem correctly.
That makes sense. Now, it seems like your background and working at Databricks, which if I remember last time I talked to people from Databricks, most of the focus was on Apache Spark. And that just might have been the sample that I got because I talked to mostly Spark people. I could be wrong. But anyway, most of the focus was on data science, right? And data science is important to machine learning, but machine learning encompasses a lot more than just data science. So how much of the book focuses on data science versus, actual like training systems and some of the other things that go into machine learning?
I mean, Not a lot of the book focuses on algorithms. You want an algorithm book, there's hundreds of them that are super great. I've read a bunch of them when I was learning all this stuff years ago, and I continue to read them. But the other bits and parts of machine learning work and data science work in general, or the overarching umbrella term that everybody uses today, AI, there's a lot of stuff that is in that sphere of influence. Everything from how to do proper ETL and how to validate your data, how to test your code, how to construct your code correctly so that it's not just that it runs efficiently, it's more that humans can read it and humans can maintain it. And you can fix it easily when it does break, because it will break. How to respond to quick changes, how to do retraining. What is your process for doing that? All the way to towards the end of the book, the last couple of chapters are focused on not so much the hype stuff in the AI world, but more of the good to haves once you have the fundamentals down. Stuff like automated ML, where you're going through automated hyperparameter tuning all the way to automatic pipeline building to make sort of boring ML use cases easier to do.
That makes sense. So when you're talking about machine learning in action, you're talking about, sort of getting your data, cleaning your data, putting your data into a system that uses it to actually solve a problem. And you're not getting into like the nitty gritty math or the deep algorithm talk or any of that stuff. You're more about, here's how you take your data set and here's how you solve a problem with it.
And it even goes further than that. It's here's how to talk to other humans. Here's how to deal with the rest of your business units and how to identify subject matter experts. Any data scientist that has the hubris to think that they can solve a problem themselves is dooming themselves to failure and a failed project. So it's talking about how to communicate with people who are non-technical in the realm of math and data science, and how to set up processes around the meta process of building an ML solution. Everything from how to do research correctly, where to go to do research to solve a problem, how to always search out the simplest solution first, how to run experimentation, how to time block experimentation, and how to evaluate your results and make sure that you're not wasting time and money at your company, but also involving the rest of the company in everything that you're doing and making it so that it's presentable in a way that it doesn't require a PhD in math in order to interpret the results of your in-work process.
It's funny that you bring that up. I've told this story probably a million times, and it's real short, but I have a brother that just finished his degree in computer science, and I have a cousin that is taking a break from his degree in computer science, which means that he probably will never finish his degree because that's kind of the way these things go, right? But at one point, they both came to me within like 3 weeks of each other, and they said, Chuck, because I have a degree in computer engineering. I've been talking about software development on podcasts for over 12 years now. And I've talked to a bazillion people. I've been in this industry for a long time, and I've coached and advised I don't know how many people. And they're like, okay, so what's the most important thing that I can learn to be successful when I graduate? And and they're thinking, I'm going to be like, well, if you learn this algorithm, right, or if you learn like this technology, or these programming practices. And I looked at them and I said, study hard. I said, the most important thing that you can learn, and I said, they're not going to teach you this in your classes, is to learn how to work with people.
Mm-hmm.
I said, honestly, anymore, they're going to put you on a team, and if you can't work with your team, they're going to let you go. And it doesn't matter how smart you are. It doesn't matter how good you are, because software has gotten complicated enough to where one person just can't do it.
Correct.
And so what you're saying here is spot on, right? You have to be able to communicate. And if you can't communicate, you're not as valuable as the person who can, even if they aren't as technically capable as you are. And so I love highlighting that. One thing that I do want to call out, and you kind of alluded to this before we actually kicked off the podcast, is, and I kind of brought this up because it's a good transition to this, but let's say that somebody just graduated from a boot camp, or just graduated with their CS degree, and so they go get their shiny new job, and they're done popping all the bubble wrap on their new job, and they're all excited to get started, and so they walk in and their boss says, okay, go solve this problem, and it's a machine learning problem. Where do they start, right? Where do they get started? I mean, I have 15 years of web development and other development experience, and I'm not sure I know where to get started with some of these problems, right? And so how does this new person coming into the field and dealing with something like this, a problem like this, where do they go?
I mean, I've lived through this back before ML was a cool thing, back before they called us data scientists. And my advice to people that ask me that exact question is, A, get ready to fail a lot and be okay with failure. Be able to rapidly learn.
That is such good advice. That is such good advice for anybody.
Yeah.
Welcome to CS. Welcome to computer engineering.
The second bit of advice is, in any production code base that you see for ML, count the number of lines of code, times that by 400, and that's how many lines of code you're going to write during the process, and then delete, because it's constant rework. And that's why early optimization or early generalization in ML is the death of a project, even more so than in traditional software engineering. So be flexible, be agile. And I do talk about that in the book of like bringing agile methodology to ML and how important that actually is. The third thing is make friends, get the support network built up in the company. And everybody's different with how they interact with coworkers and stuff. But whatever your first couple projects are, get to know the people that are on the other side of that, your internal customers. They're the people that know how to do this thing. Whatever you're building to create a solution for, they're going to know it orders of magnitude more than you can learn in even 6 months, because that team has a wealth of knowledge that, depending on how old the company is and how many people are in the team, you could be talking cumulative hundreds of years of knowledge spread out across that team. Identify some sort of champion in that group that you can go have some beers with or coffee with or eat lunch with once a week, and make that connection with that person where you're discussing the project. And then my fourth bit of advice for somebody who's just starting on a new project for the first time is just do as Einstein does or did. If you give somebody, an hour of time to figure something out, 55 minutes of questions and observing before, taking 5 minutes to solve the problem, that's much more applicable to ML problems than anything else that I've worked on in my life. Asking why we're building this, what do you want it to do? How do you want it to do it? Can be solved pretty quickly and efficiently by saying to a subject matter expert in a business unit, hey, is it cool if I hang out at your desk for a week? I want to see how you do what you do. I want to learn all the hidden gotchas that are in this realm. And then as I'm working on this over the next couple of months, is it okay if I bring you over to my desk for, an hour out of every day, maybe at the end of the day, whenever it happens to be that they have free time, and just say, hey, can you just look at what I'm doing? And I might have some questions. It's amazing how successful a project can be in ML if you start building those relationships, because you have a non-technical rubber duck at that point where you're bouncing ideas off of, but you also have somebody who knows a whole lot about that domain who can save you weeks of rework and frustration.
Yeah, that is so true. And, I've seen this. I haven't done any professional ML work, but just in software in general, right? I mean, I can't tell you how many times as a freelancer or even as a professional developer where, it's like, we need X. And so you go build X, and then you go and show it to them, and they're like, oh, we forgot to tell you about this little thing and that little thing. And They have is this what you want? Yeah, but, right? And it's, and some of it's kind of obvious to anyone who's worked in the field for a while. And some of it is, we have all of these regulatory things that we have to deal with that, you just cannot do it the way that you did it, right? And at the end of the day, yeah, if you'd been able to actually go and liaise with those people, I used a big word, I'm sorry. If you could go and sit with them and understand them, then you would have just done it the way that they needed it the first time and saved yourself a whole bunch of, because it's frustrating. you put in a week's worth of work and now you have to go through out. Yeah, my system went to sleep and it kicked me off Zoom. I don't know why it's doing that.
Oh, no worries.
But yeah, so you save yourself a week's worth of work, or more, or half your work by just understanding the nuances, the edge cases that they have in their head and seem obvious to them. And they're so obvious to them that they don't even think to communicate them to you. But
Yes.
as you sit there with them, it's, oh yeah, I picked that up, day 2, hour 3, because they dealt with that. And I asked the question, oh, well, why did you do that? You never explained that to me.
Exactly. And there's a big section in some of the early chapters that I covered, like this, a very similar situation, and talking through this is why it's important to sort of understand how the nuances are of a project so that you make sure that you're building something that you can demonstrate you're working towards what they are looking for as a solution. But a lot of ML these days, a lot of customers that I interact with now in my role, is sort of punting it over the wall. Somebody will draft up a design document for ML. And sometimes this is due to just the fear of the unknown. Like the business thinks that there's some dark magic that's happening in the data science team, or the data science team is just a bunch of cave dwellers sitting in some dark corner of the office building that nobody really wants to interact with. And it's more detrimental to project work in that situation when requirements are thrown over the wall and then people work in a vacuum and they attempt to solve this problem as best they can, but they don't have all of the details. They don't have the nuances, and they're not getting the feedback that they require consistently throughout all the phases of development. And that's other things that are talked about in the early part of the book is about how to sort of set up a timeline for a project where there's these check-ins that should be required in any project where you're involving that business unit, the SMEs, the internal champion of the project, and making sure that it's a cohesive team, that everybody's freely communicating, but in layperson's terms at all times.
Right. No, that makes total sense. It's interesting because we kind of got right into the interpersonal discussions and making sure that the project's on track and making sure that we understand the problems. One thing that I was wondering about as we've kind of talked through this is sometimes these models get somewhat obscure, right? So, we go set up the tool, whatever tool we're using, TensorFlow or something like that. And we build out the system and we feed the data in and we run whatever we're running and then we start testing the system and it's not giving back what we want.
Mm-hmm.
And it gets tricky to actually know, okay, it's not giving us what we want. How do we know where the problem is? And even having a subject matter expert, right? They may not know what was missed, right? So
they definitely won't. I mean, nobody will.
Yeah.
So the big problem there is starting with TensorFlow. I'm not going to knock deep learning. I think deep learning is amazing for what it's designed to do. So you're trying to classify images. You need to pick out components in an image and classify them.
Right.
Sure. Use Keras, RAPS, TensorFlow, MaskR, CNN. It is designed to do that job, but it's not designed to do what linear regression is designed to do.
Right.
It's not designed to do what Bayesian modeling is designed to do. And I see a lot of people these days just go for what is the hottest thing that's being talked about at any given time. So I see a lot of companies who don't have a history. They don't have people that have been doing this for a while, and they just search for solutions online. They read a blog and they're like, oh, they're using TensorFlow for this, or they're using PyTorch for this. That must be the way to do it. It's so new and so great. And it's the blackest of black boxes.
Right.
There's currently work going on to make them more interpretable, and you can do, synthetic simulations with stuff like SHAP and LIME and run explainability algorithms against models like that. But that takes a lot of time and a lot of money to do that. So the big thing that I always, try to tell people about when they're approaching a problem is if you need something that is regulatory or you need something that is explainable to people as well as to yourself, start with the simplest thing that you possibly can. And if that doesn't work, that's when you try something more complicated. There are plenty of times in time series modeling that, traditional ARIMA-based methods just can't solve that problem very well. There's too many latent variables in that, and you need to, utilize some sort of memory state that is different from how ARIMA does it. Yeah, use an LSTM. That's what they're built for. But don't start with an LSTM on a time series prediction problem.
Right.
It's insanely complicated to be able to debug and figure out what might have gone wrong in your data. And I kind of see it as a crutch that some people use because some of these high-level APIs for these advanced models are so approachable. I don't really see people doing EDA anymore. So going through, looking at a feature set and exploring it, saying, hey, I'm going to try to see for supervised learning, I'm going to check each of my input variables and I'm going to check it against my target. What is the correlation there? How interrelated are these things between my different features? How collinear are these? Am I losing a signal here? Or am I actually self-defeating a signal here if I'm using a linear model? Or people just moving straight to, when they're using tree-based models, they're like, oh, I'm going to use XGBoost. I always ask, why? What else did you test? Is this the right approach? And a lot of times I get answers like, well, that's really old and it's not sophisticated, or it's too primitive. It's like, you do know that the underlying math for how these things work is pretty much the same. It's not that it's more or less sophisticated. They're designed for different applications, and some of them perform better than others for your particular data set and what you're trying to solve. So yeah, I just urge people to read more of the older tech and how things were done, and also realize that some of these algorithms that people are talking about how amazing they are, and it's now released on Python and it's part of scikit-learn. Look at the original white paper. Spoiler alert, these are before white papers were a thing. This is back when people used to write algorithms in textbooks. Some of this stuff is in the 19th century. Some of it predates that by many centuries, the foundational maths behind how these algorithms work. We just have computers that can run them now. So I just recommend that people don't get afraid of using those seemingly less sophisticated implementations, because sometimes they're actually better.
That's funny. I was trying to ask a different question, but I got a terrific answer. I love it when that happens, because it's so true, right? It kind of reminds me of, and I see this in a lot of other forms of development, right? Where it's not the latest and greatest thing, and so we have to ditch it, right? Or, I see moving on to newer technologies when there are security concerns, or when there are speed concerns or things like that, right? And you just, you actually have some legitimate performance or, other liability concern with it. But yeah, if it works, then why not use it, right? Barring any of those concerns. And that makes total sense to me.
Yep. Particularly if it's cheaper too.
Yeah.
Right?
Oh yeah.
Cheaper, faster to develop, more reliable, more proven.
What's not to like? Yeah.
Yeah, exactly.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
What I was trying to ask was, let's assume that you've picked the right tool, you've picked the right approach, and you've got a solution that's mostly right, but you have missed some of the edge cases. How do you work with your subject matter experts to figure out which edge cases you've missed when it's still a black box?
Oh, if anybody is out there who thinks that they're going to catch all the edge cases with machine learning, sorry to disappoint. That is not how this profession works. That is not how...
I would assume not, but yeah, assuming that they're looking at it and they're going, it's not quite right. Yeah, how do you start figuring out where the not quite rights are if it's not quite good enough either?
Yeah, a lot of analytics. So run predictions against different synthetic data. If you're building a
Mhm.
prediction model for supervised learning,
Oh, that
Uh,
makes sense. Yeah, you
generate some
set up
feature
synthetic
sets.
data.
Yeah,
Yeah.
generate synthetic feature data, run it through the model, and analyze it. That's actually what Lime does, and you can
Mhm.
use SHAP as well to say, all right, I'm seeing this weird behavior from here. I'm going to run my entire training and validation set through this model, and I'm going to analyze the influence that each of these features has over the prediction space that you're trying to do.
Mhm.
And those explainability tools are really great. I highly recommend the Python SHAP package. It's phenomenal. When you're talking about stuff where it might not be as apparent when you're just doing a SHAP analysis and you're like, hey, I think we're actually missing some sort of critical business need here.
Right.
That all goes back to EDA and evaluating your actual feature set, because
Mhm.
your features are things that are correlated to whatever your target is
Right.
when you're talking about supervised learning. And we all know the old adage, correlation does not imply causality. And that's very, very
Right.
true. And that's the foundation of ML, is we can only collect so much information about the world and about a particular problem. You're talking about customers doing something, right? Like, hey, we're trying to sell this product to this customer, and we're predicting whether they're going to, show up today and whether we should have a sale or something. Whether somebody shows up to your website and buys something, or whether somebody buys that airline seat, or whether
Mhm.
this pipe is going to freeze in this oil pipeline today, all of those things that you have a model built around prediction, you're capturing way less than 1% of the actual variables that are influencing that. One of the use cases in the book, some of the chapters that are coming up for release soon, there's some ridiculous stuff in there, because I think it's more fun when it's funny. So one of the scenarios is about ice cream sales, specifically to dogs. So
Mm.
we capture so many things about our customers in this theoretical dog ice cream business. So we're capturing like the temperature of the day and what the weather forecast is going to be in these different regions around North America. We capture, what was this person's favorite flavor, or this dog's favorite flavor that they've eaten in the past, and how frequently have they come and ask their humans to buy ice cream for them. And we capture this very small amount of information, but we have no idea what actually influences the decision to buy. And those latent factors, that's what sometimes models, when we're looking at it, and the subject matter expert from the business unit's like, hey, we're looking at this model for this one aspect of our business, and it sucks. It's like really bad. What did you do wrong? It could be that you're not capturing one of the major latent factors that are actually, separating out
Mhm.
your population. You can figure that out through EDA. When you're talking about humans, I go through the RFM algorithm in the book, and about how powerful that is. A lot of people are like, oh, we're going to do k-means cluster and PCA, and we're going to figure out like what groups our customers belong to. I did the same thing in a previous life. And then some marketing person came up and was like, hey, have you ever heard of RFM? It's what we use to do customer segmentation. And I was like, no, I've never heard of this. So I looked it up and I'm like, you've got to be kidding me. It's just quantiles. This is awesome. This is going to run in no time. It's just a SQL query. And yeah, it's more powerful than any unsupervised, clustering algorithm that I've ever attempted when you're talking about human behavior. And it's
Mhm.
great. But those groups that you identify, it's pulling in data by, cohabitation association within the groups that you're never going to have access to data-wise. Socioeconomic factors that influence how people behave,
Mhm.
where, aspects about their life and their behavior patterns that are reflected in how they interact with your business, but you don't have access to all the data associated with that. And it would probably be illegal or at least immoral to collect that data, even if you could. But that grouping approach that you do can help explain what those latent factors are. That could be a feature in the model, or you could create different models for each of those groups to solve the problem and handle those edge cases in a little bit better way.
Makes sense. Makes total sense. And I like that you're kind of coming back around to the idea that, hey, there's this simpler more proven tool, right, that you can come back to that's not this,
Yeah.
fancy schmancy, let's go, tilt the world on its axis kind of tool, right?
Exactly. That applies to all software engineering.
Oh, that's so true.
There could be this super powerful, fancy new front end development tool kit or framework that you could use that may be powerful, but if all you're trying to do is create a simple pop up with a static image, just do that. HTML, CSS, keep something that's basic, simple JavaScript, and you don't need this, super complicated, powerful framework and ecosystem in order to do that. So with ML and algorithm choice in particular, the simplest option is not always the most accurate, but it's going to be the cheapest, easiest, and if it solves the problem, then it's the best solution for it.
Yep. Yeah. Well, and the thing is, and this is the thing that we always get into, like say on the JavaScript podcast when we're talking about that stuff, is people are always trying to optimize their JavaScript solution to be like the fastest or have the smallest payload size or things like that, right? And so it's like, hey, I shaved another kilobyte off of my 1.2 kilobyte payload size, right? And it's like, well, once you're under like 5 kilobytes, the bandwidth that, it's just going to load fast regardless, right? And so, yeah, it's going to load that much faster, but is your user really going to notice, right? No. Is it really going to make that big a difference? No. When it executes, does it load the page faster? Yeah, okay. I shaved another 2 milliseconds off of the load time, right? Again, does that really matter, right? And so is it fast enough? Okay. Well, then does it matter if you're using, Vue.js or Stimulus or something else? No. jQuery? No, doesn't matter. Right. And so, we're having the same conversation here, right? Can I get this out of the query from MySQL or Postgres or MS SQL or Mongo or whatever, right? Well, then, why should I go and do all this fancy stuff that's going to cost me cycles on my AWS machine, right? Yeah, I really like where that's going.
Well, the other problem is, how long does it take to do all that optimization? I mean, I've been guilty of that in the past when, years and years ago, looking at the speed of implementation. And I'm not talking about, all right, I have to, iterate through a collection of 10,000, models, and I'm going from a for loop, which there's a lot of ML that's written like that, to, asynchronous processing. But you spend so much time on, I'll give a Scala example. You can do stuff with, creating thread pools and queues and handling, distributed asynchronous processing on Apache Spark. And you can write RDD code that'll be just blindingly fast. And you can manage all of these concurrent tasks with Scala futures on each of the executors. Or you could just use a .par on an array, create a parallel collection, create a fork join pool in 3 lines of code and just say, go baby, go. So the difference in number of lines between those two, that first one that you might have shaved 20 seconds of calculation off on 500 gigabytes of data processing. Cool. Off of an hour-long execution. It doesn't really matter, but that's 1,200 lines of code to write all of that versus the 3 lines on a data frame API call and just distribute it out. So each language has stuff like that in each application. But I see people not so much. I don't really see data scientists do that too much, but you do see it. You do see people that are trying to build custom algorithms from scratch. I've worked with a couple of customers that they have those savant level people that are like, hey, this is a novel algorithm. I'm going to publish the white paper later this year and it solves this particular problem. And just like, awesome. That's cool. If you have the budget and the time to do that, and it's the only way of solving that problem, that's the right answer. But I also see people that want to do that for resume-driven development and want to get their name out there, and they create something that is
development. I love it.
And they're creating something special and unique in their minds, at least, like a framework around Apache Spark or a framework around Scikit and Pandas, and they think that this is a good idea to introduce yet another factory pattern in Python for config-driven ML development.
Uh-huh.
It's like, why are you doing this? These frameworks already exist and they're supported by massive communities. Just use that. It's going to work just fine. I promise.
Well, and you also talked about, when you said speed of implementation, the other thing that came to mind for me was, which costs more, server time or developer time?
Developer time. Always.
Yeah. If you have to hesitate about that at all, go ask your boss.
Yeah.
They won't hesitate. It's developer time. It's always developer time. And so if you just sit down and, do the work and do it and just implement it as fast as possible, and then you go back and you optimize it when you realize that it's not optimal in the sense that it's not getting the job done fast enough or well enough for, to meet the requirements that you have or to meet the business's requirements, and they come back and they say, hey, this isn't getting done the way we need it done. Then that's when you go back and you go, oh, okay, we've got to, that's when you go back and you actually optimize it. That's when you go back and you fix it.
Exactly. Yeah. The over optimization, it's just kind of showing off, in my opinion.
Yeah.
And a lot of people do. And if you really want to do that, then pick a project to work on the weekend. Don't waste your company's time to do that.
Yep.
There's plenty of cool things that, colleagues of mine at Databricks, I've seen them do in their spare time, stuff that I've done just for fun.
Yeah.
But we're not going to do that with customer code and waste a customer's time or our own company's time, because that's unethical. You just build whatever is the minimum required in order to solve the problem.
Yep. Well, and it is way fun to see how fast or how small or how efficient or how whatever, right? But yeah, that's not what they're paying you for. So like you said, find your own problem and spend your own time and money on it.
Exactly. And what in the world of ML, no business, no company, no team lead, no subject matter expert at that company, no executive cares at all what type of algorithm you're using to solve a problem.
Nope.
Nobody will ever ask, oh, did you use a GAN CNN on this? Like, was this reinforcement learning?
Mm-hmm.
They don't care. They don't know what any of that stuff is because it's irrelevant. They want to know, hey, we told you to optimize our revenue forecasts, and how close are we to that? Week over week, and how accurate can we get in the future, and how stable is it? How much does it cost us in cloud services to run this thing?
Right.
And those are the things that I touch on a lot in the book about data science. If you were to distill it down to one sentence, what the entire profession is, it's we're there to solve problems.
Yeah,
that is
absolutely.
It. Nobody cares how you do it.
It's so true. I mean, they care about what can I get? When can I get it? How much is it going to cost me? I mean, that's pretty much it.
Yep.
And so, if you can deliver what they want, you can deliver it when they want it, and you can deliver it for less than whatever it's worth to them, they're happy.
Yep, exactly. The only people that will ever care, and I don't know how much people really care, your mileage may vary, would be fellow data scientists if you're trying to show off some cool implementation. But anybody who's been around a number of years who sees somebody create a monstrosity that is so complicated that it almost looks like it's intentionally obfuscated with complexity. When I see stuff like that, I'm like, yeah, that's cool. I hope I never have to maintain that code. This is all you. You built it. You owned it. It is now your child. You shall rear it into adulthood, which means refactor it now before it becomes some sort of horrible serial killer of a code that wastes everybody's times and lives.
Yep. Yeah, I suppose you could do that to that system, but anyway, very cool. Well, let's start wrapping up. If people want to go pick up this book and get the next few chapters when they come out, we actually have a coupon code. I think it's Adventures ML. I can't remember. We'll put it in the show notes. It gets you, I think it's 30% off or 35% off. But yeah, go check out the show notes or come to the website and we'll have it in there. And we'll put a link up. But do you want to just kind of give the 2-minute elevator pitch for the book?
Yeah, it's really designed to help people get solutions into production and make sure that they're able to be monitored, that you can be able to have that conversation with the business who's asking you to build something about how effective is this at solving our problem that we are paying you to solve, and how much money is this saving or making us, and how many times is the data science team woken up at night in order to support this. So it's the framework for defining problems that you're going to be solving and how to solve them, how to go about it in an agile, influenced way, how to build a good, solid team around a project, and then how to maintain it. So that's pretty much what the book's about.
Good deal. All right. And how do people find you online? I'm assuming you're on like Twitter and GitHub and stuff.
GitHub, yep. Most of my stuff is private because most of the stuff that I write is for companies or my own company. You can check out the AutoML toolkit if you're curious about a borderline monstrosity of a code base. Databricks Labs, it's all Scala. Sorry for all the Python people. It's kind of interesting. Genetic algorithms and has a different way of hyperparameter tuning as opposed to TPE. And yeah, you can find me on LinkedIn. Just search Ben Databricks. I'll show up.
All right, good deal.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
All right, well, we're going to go ahead and wrap up. We do have one more segment. That's picks. And picks are just shout outs about stuff that we're enjoying, right? So it could be TV shows, could be books, movies, could be developer tools. I mean, anything like that, right? One thing that I'm going to shout out about is we just launched a new podcast on devchat.tv. It's called She's in Tech. It's a bunch of ladies from This.Labs, which is a consultancy. They're kind of based all over the place. My friend Tracy Lee is a co-owner of the company over there. And so it's her and, like I said, a few other ladies from over there at This.Labs. And they're talking about just being a woman in technology and development. It was funny because I listened to the first episode and I'm like, this is solid advice for anyone who wants to be in tech. So, some of the advice was, I guess, a little more specific to women, but most of it was just solid advice for anyone who wants to get into tech. So if that's your cup of tea, go check it out. And what else? What else do I have? I've been spending a lot of time actually working on finding sponsors. So if you know of a company that would be a good fit for this or any of our other shows, we have shows on web development topics. I mean, pretty much any of the major web frameworks, programming languages. We also have machine learning and freelancing. I would love to hear from you, and I would appreciate the introduction. And so you can go check that out. And then I've also been using a tool, and I've used it in the past, but I've been using it a whole bunch more lately for coaching on the Dev Heroes Accelerator. Essentially, I've been coaching people on how to build their career kind of beyond senior developer into building influence so you can get what you want from your career. So I have people who are trying to build freelancing practices and trying to build just influence where people come to them and invite them to come speak at conferences and come on their podcasts and stuff like that. I've got another guy who's trying to become sort of the major voice within the Flutter community because they kind of lack in major influencers in that space. And so we're working on those kinds of things. But besides our weekly calls, they can get a hold of me through Voxer. And what Voxer is it's kind of a walkie-talkie app. And so I'm going to pick Voxer. What it is you there's a big button at the bottom of the app, and you just hold it down and it records your voice. And so you can speak to me and it'll record, and then it sends me the voice memo. And then I can just hold down my button. I can speak back to you. And so it's kind of time distance. One of the guys that I'm helping out is, he's like 8 hours off from my time zone, right? And so if he has, something that he needs help with, he'll send me a message, and then I'll get it. If it's in the middle of the night, I'll get it in the morning when I get up, and I can just message him back. For the others, they're like Eastern time zone. And so, most of the time I can get back to him pretty fast. But it's pretty convenient. You can type or voice. And I'm really enjoying that. And I stay in touch with a few other people on there. So I'm going to pick Voxer as well. Ben, do you have some things you want to shout out about on the show?
I don't have time for anything right now except writing and and work.
I have written a book. I know how that feels.
Yeah, it's pretty intense process. Yeah. I thought I rewrote a lot in code, but no, rewriting in a book is far more voluminous. Yeah, can't really think of anything that I'm really looking forward to. Getting involved with a lot of these new data and AI communities out there. An author that you had on your podcast a couple of months ago, Alexei Grigorov, started a new Slack-based community, Data
nice.
Talks. Definitely check that out. It's a rapidly growing community on that Slack channel. A lot of experienced ML folks, data engineers. People talk about Apache Spark, distributed ML, and just in general, it's a cool place to share stories and meet some relatively famous people in the space. So definitely check that out.
Cool. I'll have to check it out. If you want to just put the link in the chat, we'll make sure it ends up in the show notes. And yeah. Well, thanks for coming. This has been fun, Ben.
No, thanks for having me. This was a blast.
All right, folks, we're going to go ahead and wrap this up. Thank you all for coming, and we'll have another one at you next week. Until then, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.